Hello everyone. So today I will discuss problem Ceil division which came in educational round 101. So first I will explain the problem. So we have given an array of size n in which every element ai is equal to I uh, like if n equal to 5, so we have given elements from 1 to 5. So now what we have to do, like here length of the array is 5, so we have to divide the numbers and we have to make numbers equal to 1 4 times and 2 1 times. So basically, as given in the question, we have to make n minus 1 once and 1 2. So for making that, we have one kind of operation. Let's suppose this element is x and this element is y. So we can change this x to x by y, and it is a Ceil of x by y, not floor function. Like Ceil function will denote y like this. So if we consider this example, so we can divide 5, let's suppose we can divide 3 by 5. So array will become 1, 2, 1, 4, 5 because 3 by 5 is almost equal to 0.6, so it will become to 1. Again we can divide 4 by 5, so array can become 1, 2, 1, 1 and 5. Now we can divide 5 by 2. So array will now become like 1, 2, 1 1 and 5 by 2 is 2.5, so it will see 3. After that, we can divide this 3 by 2, so array will become our 1 2 1 1 and 2. Again last time just we divide this 2 by 2, so array became 1 2 1 1 1. So you can see we have taken 1 2 3 and 4 5, total 5 operations for this. And number of operations available with us equal to n plus 5. So here n equal to 5, so number of operation available with us is 10 and we have done 5 operations. So we have to think how we will do for this for large number. So let's take an example, like we have elements from 1, 2, 3 up to n. So one thing, like we can easily feel, we can divide any of this number with n and all will become 1. So we can try to do that, like this is already 1, so we can keep this as 1. Now we can divide 2 by n, so it will become 1. 3 by n, so it will become 1. So like that everything till n minus 1 will become 1, and here it will remain n. So total we will have n minus 1 times we will have 1 and 1 times we have n. Now our task is to convert this n to 2, but it is not possible because everything is here once. So we necessarily have to keep at least one element here. Uh, we can't make at least one element to 1. So we keep one element. Like we have 1, 2, 3, and in between some element x is there and till n. Now again we will repeat same thing and we will make everything 1 except this x. So everything, let's suppose, change to 1 and this x will remain here, and now we have n. Now task remaining to convert this x and n to 1 and 2, because at least 1 2 means exact 1 2 will be there. So for converting we can't change x to 2 because n is greater. So if we divide x by n, so it will always equal to 1. So it is necessarily we have to change n to 2. So in few operations we can, let's suppose we have changed to it to 2. So we will remain with x in between, everything again 1, and this will change to 2. Again x is remaining, so we can't uh, got all 1 and 1 2. So for changing this x we again need any one element. So by this we can recognize it, that for changing one element we need other element. We will not able to reach to the solution. So optimal way is to do is this, let's again consider till n. So 2 is already there, so let's keep this 2 as it is, and we can try to make all these element as 1. And for making this all element as 1, we have to divide something for every number which is greater than that number. So from 3 to n minus 1, n is available. So we can easily do that. But for n, we have to divide by something smaller and we have to make it as 1. So let's suppose we have done like that and we have converted everything to in between 1, 1. And now we left with n. Now we will divide n with 2. So for doing that, we will need, and for converting it to n to 1, we need at least log n plus 1 operation, and log base value is 2. And as in the question, n is given 10 to the power 5. So this value is up to 10 to the power 5. And I think almost log 10 base 5 is equal to 20, around 20. So it will be almost, you can say, equivalent to 20. So you can say for converting this from 3 to n minus 1, we need n minus 3 operations. And for converting this n, we need 20 operations. So total number of operations we will need n plus 17. But operations we have available is n plus 5. So obviously we can't do this method also. But by this method, we can find that we can see that we can keep any number in between, and through that we can make n as 1. Like again, we can see by an example. Like we have 1 to n, and let's suppose we kept element x in the between, and except 2, 1, x, and n, everything we have made equivalent to 1 using this n. So everything has changed to 1. This x is remaining and all other things changed. For doing this, we will need n minus 4 operation because this and this is remaining. So we using n minus 4 operation, we have done this. Now our target is to make this x and n as 1. So for making this n as 1, we can keep on dividing n by x. Then this n will change to 1. And for making this x as 1, we can keep on dividing x by 2. So then this x will change by 2. So we have to find out what number of operations we will require to do this. So for changing n to 1 by dividing by x, we will require log n base x of x plus 1 number of operations. And now for changing this x to 1 by dividing from 2, we again need few log x base 2 plus 1 number of operations. And we have already taken n minus 4 operation for changing these all elements. So we can say n minus 4 more. And this total number of operation can be almost equal to, or you can say less than equal to, n plus 5. So you can cut this n and you can say we have log n base x plus log x base 2 less than equal to 9 minus 2, 7. So now we can put few value of x and we can try to find any solution. Like I have tried to, like we can say that it's better to put in terms of power of 2 so we can identify. So if you put x equal to 32, you can like identify this inequality is satisfying. For x equal to 64 also this inequality is satisfying. So yes, so we can take this x as value as that and we can try. Yeah, so now let's move to coding part. So we will take n as input from user, and if n is less than 64, so we can directly perform the operations. Like we will take from 1 to x number is given, so we'll make everything like 1, everything from 2 to x minus 1 as 1 by keep on dividing from x, and x we will make as 1 by keep on dividing from 2. So we can initialize in variable x as n, and till it is greater than 1, we will keep on dividing it as by 2 and we will always take Ceil will run. So we can right, get serial. And we have to count how much operations it will take. So we can initialize it in counter variable. Yeah. So total number of operation will be our how much in counter variable, and some more operation we will use in between, that will be equivalent to n minus 3. So we can write that also, and now we will print this number of operations. And in question it is also given that we have to specify that all integers what we are deleting. So first we will delete every integers from 3 to n minus 1. So we will present that for I equal to 3, I less than n, I plus plus. We are deleting I by n. And now we keep on deleting n from 2. So that number of operation is available in counter variable. So we can specify that. So first part is completed. Now we have to change the solution when n greater than 64. So when n is greater than 64, then we have to choose a number x in the between, and from that we will divide 64, and that number we will divide by 2. So just I think we can copy this part and paste same here. And now when we will keep on dividing that number by 64, we take two counter variables here, and we have also make some changes because we have to delete 64 also from 2. So we initialize 64 in our variable x, and till the time it is greater than 1, we keep on dividing it from 2. So we here write Ceil division from 2, and we will make counter 2 plus plus. So we initialize already. Our total number of count will be counter 1 plus counter 2 plus here n minus 4, because number of elements in the between will be n minus 4. Here I written it. Yeah, n minus 4. And again we will print the total, and from 3 to n we will keep on printing, but we have to check if I is already equal to 64, we can't divide, so we will make here continue. And till the time counter 1 is positive, we will keep on dividing it from 64. And till the time counter 2 is greater than 0, we will keep on dividing 64 from 2. So we can specify it here. Yeah. So let's run on the sample test case and try it is working or not. Yeah, it is showing 2 and 3, and let's submit the solution. If we have done anything wrong here. Oh, this will be counter 2 minus minus, not counter 1 minus minus. Let's resubmit it again, because I think it is going to idleness limit exceeded, or time limit exceeded key. Yes, it got accepted. And same thing we can do for 32 also, like we can change here to 32, and here we can make some changes, like we have to keep on dividing x from 32, and we keep on dividing 32 from 2 while printing here. So we While printing also will make your changes. Wrong answer. I think while speech and we have done some mistake. Oh yes, this I will change to 32. Yes, it got accepted. Yes, so this is all for this video.